the right track. This is the platform track right now. So we're going to be talking about beyond virtual machines, serverless, and the serverless offerings we've got available in the Azure platform for us. Can I make sure that everybody around the back can actually hear me as well? Can you, a few nods, yeah? Good. I'm going to try and keep this voice up. If you're starting to lose me at any point, just put your hand up, wave at me, do anything to get my attention. I'll crank up my voice again. But I am trying to savor it. So, as we've already said, it helps if you switch this on. Right, there we go. So you're on the platform track. My name is Danail Dimitrov. I work for Grey Matter Limited as a cloud and infrastructure solutions specialist. So I work with a lot of our partners to bring them on to the Azure platform, to modernize their applications and adopt really the best services that are available for them to achieve a cost saving moving forwards. I'm not a developer, so you will see me cut and paste code into my examples. We can talk about that code later if we've got time. I will be able to analyze some of it for you, but I do, in the interest of time, we're not going to go into too much detail on the dev side of things. So, in today's session, we are going to cover serverless, what serverless is, what our definition of serverless is, to make sure that we're all on the same page, and then we'll look at the Azure ecosystem. So we'll look at the different services that are available to us, which are Azure Functions, Event Grid, and Logic Apps in the form of serverless on the platform. So what is serverless? Right, so serverless is a full abstraction of servers. So it means that you only focus on your code. You don't need to worry about managing the capacity. You do not need to worry about managing the availability. There's no upfront cost. So serverless is also instant. What that means is you provision your code. Your code is ready to execute there and then. Again, you do not need to scale anything. Your code is ready to react to events. The platform intelligently monitors the demand on your code and it scales that out, copies it to more nodes, and it makes sure that you can meet that demand moving forwards. And serverless is ultimately pay as you go. So with serverless, you don't need to commit upfront. You don't need to say that there's X number of cores and X amount of RAM that is going to be dedicated to your instance. That will and you don't need to pay for that upfront. So you pay based on the number of executions, the number of operations that you're actually consuming. So there's no upfront commitment as well. There's no static fee that you pay for on a month-by-month basis. So I'll start off by talking about the balance of responsibility. Those that were already on the platform track would have seen this diagram. So you've got on-premise, of course, we have to manage everything in the environment. We step away from that by adopting the cloud. We go into infrastructure services. We only need to look at everything that's basically from the operating system layer upwards. The virtual machines, the underlying hypervisors are all taken care of for us. The networking element is all abstracted for us as well to use on the platform that we're adopting. Then we've got platform services, and platform services is a great place for us to be. With platform services, we abstract away even more of the management piece. Microsoft can do that for us. There's no need for us to invest any time in managing our infrastructure. And we can adopt platform services such as Azure SQL, which we'll talk about later, and some of the other platform services that we'll cover in some of the other sessions. And where I think serverless really sits is somewhere there. And you can challenge me on this, but the reason why I think that serverless sits somewhere beyond PaaS, but somewhere before SaaS, is for the reasons we've already mentioned. So with platform services, you still need to determine exactly what is going to be running your platform. You still need to say, pick a size of a plan, for example, for a web app that's going to be tied in with resources that are going to then run my web app. With serverless, we don't do that. And I think that's where it abstracts away, and it's one layer beyond platform services, really, for us. And of course, serverless is all automatic, so we don't need to do that either. It's all done for us. So what are the benefits? The first benefit, of course, being focus. We can now focus on the code. We can focus on the business logic. We can focus on the problem. We're not focusing on the technology that's going to underpin the code that's going to execute. We can then achieve greater efficiency. So we get a shorter time to market because we're not wasting any of our time with all of this menial stuff. We're not wasting any time trying to determine our infrastructure. We can focus on the code and we can achieve a better, faster, shorter time to market. We're also saving costs with efficiency because we're not committing up front. So we're paying based on those executions. So that is two different areas where we're eliminating waste because we're not wasting effort, we're not wasting money, and we're able to achieve that greater efficiency right there. And lastly, we've got flexibility as well. So we're able to develop loads of different components, and those components piece together. We're able to iterate on those components, come up with new versions. We're able to experiment with new technology because we're not having to then worry about all of the other menial stuff. So that is where we add a lot more value to our customers by being able to constantly iterate through and come up with new iterations of our code that we're going to develop and deploy to them. So having said that, we've got the Azure ecosystem. And I've already mentioned in the Azure ecosystem, we've got 3 bits of 3 different services which facilitate a serverless architecture and microservices. So what we've got is we've got Event Grid on the left-hand side, we've got functions in the middle, and we've got Logic Apps on the right-hand side. These services integrate with one another. So if I want to, I can have a Logic App monitor my emails, I can have it monitor my Twitter feeds, I can have it integrate with BizTalk as well on-premise if I really wanted it to. And that can then trigger off functions. It can talk to Event Grid, and then other subscribers to my Event Grid can then action on that. So these services integrate with one another nicely, for starters. But these services also integrate with the underpinning platform. So if I wanted to use a function to modify a database, such as the case in the example we're going to be talking about later, then the functions actually natively integrate with the databases. If I want Event Grid to trigger an event based on my storage, so for example, when a new file is created, we can do that because there's that integration between Event Grid and the underlying platform. And such is the case with some of the other resources that we've got available. So actually in our Logic Apps example later, we're going to be talking about intelligence and cognitive services, and we'll actually leverage cognitive services within our Logic applications as well. And of course, they also integrate with the tools we're already familiar with. So you may already, for example, be using Visual Studio for your development. In the example with Functions integrates with Visual Studio. So I can use the same deployment tools, the same development tools to develop my functions moving forward, really split that application down into individual functions. And I can also integrate with things like Azure DevOps. So if I've already got a build and release pipeline and I'm already releasing my code into a platform out there like web apps, we can just modify the existing build pipeline, and we can then deploy to Azure Functions instead. We don't need to re-architect the whole thing. We just need to tweak a couple of areas there. So that's when we go into function as a service, if this picks up ever. Function as a service. So what is function as a service? Function has a single responsibility. So that function will take an input, it will carry out some form of process, and it will spit out a return, or an output as we call it. A function has a short lifespan, so the function is only live for the duration of its execution. Once that function finishes executing, that code is scrapped, and that frees up resources for us to then leverage with other functions that we have configured in our environment. A function is stateless, so a function will not retain any data in itself, but also a function is not dependent on another process having a particular state. So typically, a function is stateless as well. Functions are event-driven. So we could trigger functions on a periodical basis. We can have a schedule. So if we know that we need to trigger a tidy up task somewhere because our systems are not perfect and sometimes there is the need for us to do that, then we could trigger on a periodic basis. We can trigger based on a metric. So if something happens and it impacted our environment in a negative way, then what we could do is we can constantly monitor our environment, and we can have that trigger a particular function to act upon that. We can also trigger based on other functions. So if we have a particular output from a function already out there, then we can trigger another function in our environment as well. And of course, functions are scalable, as already mentioned. The platform will monitor exactly how many requests we have. As we see a trend and we see that demand increase, as already stated, the underlying resource will be increased. That function will be copied to more nodes where the demand is required, and it'll be able to facilitate our demand moving forwards without the need for us to even do anything. So, building upon that, we've got Azure Functions. So Azure Functions keeps all of the mentioned features we've already talked about in a function as a service kind of platform, but it also extends that with additional capabilities. So in the Azure functions, we've got triggers and bindings. With triggers, we get to define exactly what it is that invokes our functions. And with bindings, we get to tell our function, we get to define what our function integrates with. And that's abstracted away. So we don't have to define that within our actual function, within our code, and create all of these tedious connection strings that we need to keep on top of. We can predefine our triggers, our bindings, and all of those integrations are already taken care of for us. We've also got the integration with other tools. So, as already stated, it integrates natively with things like Visual Studio, so we can develop exactly in the tools we've already used to. And we've got host and option flexibility. So we've got a number of different options available to us. So 3 options for me to mention in terms of host and option flexibility is app service plans. So for those of you out there who are already using web apps in your environment, you're already hosting web apps off the back of an app service plan, which is based on the pricing tier. What you can actually do is you can actually host your functions inside the app service plan you've already got provisioned to save on you having to pay for that function individually. But ultimately, the whole benefit of serverless is that we pay for what we consume. So if you're not using an app service plan already that you want to make use of, then what you can do is you can leverage a consumption plan. So with a consumption plan, you pay for exactly what it is that you use. You pay on the number of transactions that you're consuming. And a consumption plan is fixed on single core nodes with 1.5 gigs of RAM. And your functions will get replicated across to more nodes, but you will not be able to do multi-core hyper-threading kind of performance. You will not be able to get that from a conventional consumption plan if you were looking to achieve that. But what we now have as well is we've got a premium plan, which is currently in preview. So in the premium plan, our nodes are up to 4 cores with 14 gigs of RAM. So that's a big improvement over what we've already got. We can leverage extra features. So we've got VNet integration in our premium plans as well. So if we wanted to integrate with other services on the platform already that are talking through a VNet, such as traditional infrastructure services or potentially web apps with service endpoints as well, we can integrate with those through our internal virtual network. And you pay again for your consumption with a pre-warmed instance. So the idea with a premium plan is you're able to achieve greater performance. You're able to scale a little more quickly than you would in a conventional consumption plan. And that's why we pay for a pre-warmed up instance as well. So we're paying for that to be available, always on standby, ready to deal with that peak in performance that peaks up unexpectedly. So with, again, a few more sales slides here. With Azure functions, we're able to boost efficiency. So each function has one trigger and one trigger only. A function will be configured to respond to a certain type of event, whether that's a particular webhook that gets called, whether that's a timer that gets called. Now, a webhook can have multiple bindings. So as already explained, you can integrate with multiple systems. There could be input bindings, there could be output bindings, and you can use any number of those with each individual function. Functions can integrate with function proxies. And what a function proxy allows you to do is, as opposed to having all of these different functions and different consumption plans being called by different service endpoints, so are you having to identify different URLs every single time you want to introduce a new function in your environment, it allows you to manage that. So you can leverage a function, configure it with a function proxy, and then it behaves as one coherent API. So you've got one interface that's able to service all of these endpoints that are now present as different functions in our environment, and allows us to achieve the same level of integration we'd be accustomed to in the traditional API interface. Azure Functions integrates with core tools. So it's got Azure Functions core tools allows us to actually test our functions locally on our machine. It allows us to see how our functions are going to behave. We'll see that in a bit shortly, but it allows us to also connect to Azure services on the platform. So if that function already talks to other services, we can debug locally, but we still have that interaction and that connectivity to the other services that are available on the platform as well. So we're not missing out by debugging that locally. Also, in terms of continuous integration, Azure Functions integrates with services like Bitbucket, Dropbox, GitHub and Azure DevOps as well. So we're able to achieve that continuous integration. So if we wanted to continuously iterate through our solution, introduce a new version of our solution, what we can then do is we can configure continuous integration with functions to constantly iterate to the later version when we're committing new code changes to the function as well. So, of course, last but not least, let's not leave our monitoring. For those of you who have heard of Application Insights, which is an excellent tool for monitoring the performance of our websites and web apps. Azure Functions also natively integrates with Application Insights. So through Application Insights, we're able to see exactly what calls our service, where those calls are being made from, how long it takes for the function to execute, if that function is then calling other services, whether those services are holding anything up, if we're not able to fulfill certain requests because we're experiencing errors. With Application Insights, we can see exactly what those errors are. So we've got that native integration with a tool which is already so great with web apps. So we can also boost flexibility. So as you can see, Azure Functions currently supports C#, JavaScript, F#, and Java. Microsoft is constantly working on the serverless technologies. So they're constantly working to extend that capability to new languages as well. So if you're already a C# developer, you're covered. If you're a C++ developer, then you need to get learning. And there'll be some other languages obviously introduced on the platform moving forwards as well. We've already covered the fact that there's numerous hosting options available to us, but what we've also got is we've got durable functions. So now, on the serverless technology, we've got this introduction of durable functions, which is a stateful workflow on top of a serverless environment. So if you have a function that needs to call another function and it needs to wait for a return from the other function, that would not be a definition of a stateless function. But what we've now got is we've got durable functions. So durable functions can execute, they can call out other functions, they can capture the output from the other functions and store them as local variables. And there's a whole checkpoint process in place to make the whole thing resilient. So the service will checkpoint the different stages of the function. It will checkpoint when the function calls other functions. It will checkpoint after it calls the other functions, so that if the underlying infrastructure restarts or any of the VMs restart, for example, it's not just in memory, you still get that progress and all of those variables are retained. So that's what durable functions does for us. And of course, we've got dev tools as well. So it's not just Visual Studio that we integrate with. We integrate with Visual Studio Code, CLI, etc., etc. There's other tools, and that list is constantly growing as well in terms of the dev tools that we can integrate with. So we'll dive into a demo of Azure Functions. This will be interesting. Let's hope it goes well. So I'm tethering through my phone right now, and what we're going to do, so I'll bring this up, is we're going to create a brand new function. So I'm going to use Visual Studio 2017. I do have 2019, but we have a love-hate relationship at the moment, and it doesn't want to listen to me. So in the first instance, I'll define a new project. It'll be a C# function, and that C# function will deploy into my environment. So let's have a look. Visual C#, Azure Functions. I'll store it locally where I can find it. And I'm going to try and show you as many demos as we can throughout today so that you can really see this technology in action. It's all good. It's no use for me to just talk about technologies if those technologies do not work and don't actually fulfill the needs. So we'll call this event ISV, and we'll call it function demo for lack of originality. When we refer to it later, we know what this is doing. Now, with this particular function, I want it to be triggered by an HTTP trigger. So there'll be an endpoint that will be called to trigger off this particular function. And what I'm actually going to do with this function is I'm going to update a table in a database. So whilst that is loading, fire up SQL Server, and we'll connect to the database, which will demonstrate the data that I'm modifying in our environment. So there'll be a few different things for me to switch between. So for starters, I have this particular database in my environment. It's called Event ISV Serverless again. And what I'm going to do is I'm going to connect to this to show you what the data in that particular environment looks like. I'm going to leave this up here, hopefully get some better signal. Okay, so I just need to tell my environment that it is to accept connections from this particular IP address that I'm trying to access it from. And I'll do that quickly here. And I should be able to then connect to demonstrate what my data currently looks like. So my database, you'll see that I've got, once this loads, two tables. I've got a table of customers, I've got a table of addresses, each with 4 records of test data. I'll wait for that to connect. And we'll see if the demo gods are going to connection timeout. Trying to get through here. Oh, so what tends to happen? So we've got the IP address here. We have actually saved. We'll wait for that to event ISV. Event ISV SQL Server. Okay, we'll wait for that change to actually replicate across. It seems to be taking its sweet time. So what we're going to do is we're going to actually move on to the actual function. So what I'm going to do is, in the first instance, I'm going to try and publish this function. So I will create a brand new function in my environment. And I can do that a number of ways. So I could do that from the top by typing in Azure Functions, or I can go through the plus sign up here for a new resource, and I can search the marketplace. So if I type in Azure Function, we should, there we go, function app. Should be able to create a function app. I'll call that function app event ISV demo. Hope it's not taken. Thank you everyone else. And I'm going to pick the resource group to build this function app in. I've already got an app service plan available, so I'm just going to use the app service plan I've already got. I've got a serverless one here. I want it to run on the .NET runtime stack, and I wanted to use a storage account I've already defined. So some of the functions require a storage account to underpin those particular functions so that they can execute. I've already defined a storage account in this particular case, so I'm going to use the storage account I've already created to make this a little bit quicker. And that application insights integration is native from the creation screen, so I can enable application insights right now. But again, in the interest of time and making sure that everything's going to deploy quickly for us, I'm going to disable that, as we haven't got any time to look through the kind of data that the application insights will provide us with. So I'll let that run in the background. This should take a couple of seconds, maybe up to 30 seconds to provision, because it's already provisioning off a plan that already exists. So there's delegated resources for me already. I just need to create an empty plan, an empty app. And I can click on the deployment here to find out what the status of that is. So we can see it's accepted the storage account because that's already created. It will do the same with the app service plan, and it will actually deploy the application. There we go, and it's already deployed that. So if I click on my event ISV demo, I've got this particular application here. I've got the URL I can also access the function from to see that the function is currently up and running over here. What I'm going to do now is I'm going to deploy this box standard function from here to my new Azure function. So I do project, actually build, publish, and I'm going to publish this. So we'll start a new deployment. We'll use an existing function app. Re-enter my credentials. MFA. This is what I was using in 2017 as opposed to 2019. It usually doesn't do this bit. Okay, we'll approve that. We should see a list of the resource groups that we have available to us. Okay, so I've got my CDFG events, and I've got my event ISV demo that I've just created in my environment. So select that. And what I'm actually going to do is I'm going to manage my application settings in the first instance. So this is going to trigger a build. I'll carry out one more build because what I want to do is I want to define my connection string outside of my function as opposed to inside my function, and I want that accessible through the portal. Later, if you're sticking around for the data side of things, we'll show you how to manage those connection strings in a more secure fashion through Azure Key Vault. But we're not going to go into that in this particular demonstration. So we can see that our app is already building. Whilst that's actually building, we're going to go and fetch the connection string for our application. So that connection string can be accessed by going to our database server. And from there, if I go to connection strings over here, I can see the format of an ADO.NET connection string. So I'm just going to copy that from there. And that's how we acquire that. That's currently got everything in there aside from the username and password that we need to populate, which we will fetch out already. So now that my publish is done, I'm going to manage the application settings so I can see the configuration for this particular function app as it's been deployed. But what I can do is I can add a new setting. And with that new setting, I'm going to call, just to make sure that everything's still going to work absolutely the same way, I'll call it SQL connection, SQL DB connection, which is referenced in my code. And then what I'll do is I will copy the connection string from the database server and paste that in there as well. So paste that. I'm going to edit my username and password, and I have purposefully made this highly insecure. So do not judge me. I think that the rest of my passwords look like this. So as you do, to satisfy a capital letter and a number, of course you go with password 123. It just means that the demo is going to be smooth. Touch wood. And whilst that's saving, that's actually committing that change to my function. So if I navigate back to my function in my portal and I explore the function, what I can now see is that this particular variable is actually stored there. Event ISV demo. If I go to function app settings and go to manage application settings, because I've got the right level of access on the function app, if I go to, okay, that hasn't committed yet. Let's just publish that again. Try that again. SV demo, publish, done, and we go to the application settings. I'm probably looking at the wrong web app. Or the portal is caching in a crude fashion. Oh. That will change in a bit anyway. Once we commit, we'll have another look. I believe caching is currently playing up for me in a really bizarre way. So what we'll next do is we'll just add a new NuGet package to allow us to call out to a database from inside our function. So go to manage NuGet packages and browse for this particular package, which is System Data SQL Client. Install that in the project. Okay, that quickly. Accept. And that will install the package available for me to use in our solution. I will quickly just copy some code in there as well to demonstrate how this works. So I'm going to use a new library and call that library from that particular package in here. And then I'm going to change my function. So all I really need to do is change the main body of the function. because I don't want to change the trigger around it and what my app is configured to respond to. And this should now, with any luck, just build for us. Brilliant. Just going to try and connect to the data again. So it's only good if you can demonstrate it works. Okay. Right. And if I quickly try and do that one more time, event ISV serverless. It's on the ISV database server. Change my firewall settings again. Oh, it says a slightly different client IP. Do that manually because it clearly got read in a different way. And we should finally be able to connect to our data. So this particular statement is updating my customer table. It's looking for a user called Jake, and there is a deliberate mistake in there. So again, all mistakes are intentional. Mistakes are learning for us. So there is customers here, and it'll look for this particular record called Jake, and update Jake to how his mum loves to call him, which is Jacob. Theory. So we've got that customer over there. So this is how we can verify that this is running. So in this particular case, what I'm going to do is I'm actually going to build my solution, publish it again with the changes I've just made. Because it's built successfully, I know that that actually works and it compiles. Event ISV demo. And now what I can do is I can call Postman, call my function, and see whether my function works. So the way I'm going to call my function, when I declared my function, I told it that I wanted it to only be called in a secure fashion for a token that gets passed in. So what I can do is I can actually find what that token is so that I can call the function. So if I navigate into the function itself, just wait for it to load. I've got function 1, terrible naming convention. I can't edit function 1 because this has not been built in the portal. I can merely just view information regarding my function. And one of those should be the connection string that I use to actually call my get method, get HTTP request. It's taken a little while. Demo gods are definitely not with us. There we go, get function URL. With my function key, I'll copy that, paste that into Postman, do a get request, and I'll send that request off. So I'm just going to use a post method. Please pass the name of the query string or in the request body. So this is not working fine. This is actually just giving me a generic error message that I had configured in a very terrible way. So for me, what I can actually do is, because this is currently erroring, what I can actually do is navigate back to the... Oh, our publish didn't work. Published failed to deploy. If we just try that again. I think we tried to call our function a bit too early, and sometimes when you try and call function at the same time, it locks up the function, so it's not able to be overwritten by a publish from our Visual Studio IDE. So ultimately what you end up with, publish succeeded, if this works, you should be able to call this. And you get a particular error. You'll get a 500 here. The reason why it's given you a 500 internal server error is because I made a deliberate mistake. But what you can actually do is leverage those tools already available to us. So as I said, you can actually debug locally. So we can run our function locally and we can determine what the problem is by calling the function locally through Postman. But we are severely running out of time. So what I'm going to have to do is move on if this doesn't work any quicker. Right, so this is taking a little too long to debug locally. It's definitely not liking it. So instead, what I've actually done is I've rectified the mistake. The only reason why this is currently erroring is because I'm trying to reference a particular table value, a particular column, as opposed to actually inputting specific values. So I haven't actually put my values in single colons, and I can prove that by testing this locally and sending a post request locally. This will currently error. Try to execute. And it's basically saying column Jacob does not exist. The reason why column Jacob does not exist is because I was being a bit of an idiot. I deliberately didn't encase this in columns, in single quotes, sorry. And because of that, it thinks that I'm trying to reference a different column inside my table, which evidently does not exist. And if I do this again and try and debug, because it should be quicker than me trying to redeploy the app to prove that it works, second time round, and I call the same function, which is probably on a different port by now, 7071. No, we should be okay. Now what we should see is we should see the function succeed, and if I was to view the contents of this table again, Jake should change to Jacob. So theoretically what we can do is we can use Azure Functions to constantly update my data if it makes the change. Still trying to do it. But I believe I'm having a few connectivity issues with my phone, to say the least, right now. So this would in theory change, and soon this should reflect the new value of Jacob. Anyway, moving swiftly. Now that you've seen how we can debug issues ineffectively, what we're going to do is return to the presentation in the interest of time. Now, the next bit for us to go over is events. Of course, you've got these different functions, you've got different services that integrate with one another in the background constantly. That is a pain for us, because for us to manage how these different services integrate with one another is quite difficult, keeping on top of what is talking to what. They're talking to each other in a different fashion. They're using different means to communicate with one another, because the calls are not going to be consistently the same. So how do you manage events from one place to another on the Azure platform, especially with all of these serverless micro technologies? What we've got is we've actually got one service called Event Grid. So with Event Grid, we're able to actually map and manage everything from a single location. So what we've got is we can integrate with loads of resources available on the platform already, and we can call out things like from all of these different services. What we can do is we can call things like functions, logic apps, automation with runbooks as well in there, and we can manage all of this communication in this one centralized place, so we're not having to keep on top of it by different means. So if we look at what that looks like in the portal, you create what we call event subscriptions. Now with the event subscriptions, you have publishers on the left-hand side. The publishers are the different services that are going to be publishing events. They're going to be what's triggering those events in our environment. Then you've got these subscriptions that inform the handlers and the handlers is effectively what's going to then carry out that particular event. So what's going to receive and consume and actually act on the events that you have triggered. Now, with Event Grid, it is obviously a fully managed service. It's fully managed for us. It performs in near real time. So in adopting a service like Event Grid, essentially a service bus kind of service, we're not introducing any delay because Event Grid can scale and it can manage all of these calls for us very quickly. And it's got a broad coverage as well. So that coverage is constantly being changed. So at the moment we integrate natively with storage accounts, things like event hubs, etc., custom events, but there is loads that are currently being worked on that are being added. And I'm sure that some of these have already actually made their way into Event Hub already, into Event Grid already. So Event Grid actually gives us reliability and performance. So it gives us actually 99.99% SLA. So that's very high availability for us. It also is able to scale up to 10 million transactions per second per region. So we can scale a lot of events here that we can trigger all the time. And Event Grid can also retry, so it's got quite robust retry mechanisms. So you can retry for up to 24 hours if you wanted to in the event that your service was not able, in the event that your event was not able to be delivered to all of the actual subscribers that are subscribed to it. So how does pricing work on a service like this? Event Grid is actually, well, it only costs us 60 cents, and it only does that per millions of transactions, and that is only after the first 100,000 free transactions per month that we are entitled to. So a service like this is very easy for us to adopt because there is no upfront commitment. Again, reiterating that point that we're not paying for anything until we really start consuming and start making the most out of this platform and consuming effectively, because for you to generate 100,000 transactions, that takes some doing. From past experience. So if we look at a very quick demo, again, cautious of time, of what Event Grid looks like, Event Grid is very simple for us to set up. So in this particular case, I've already provisioned some services. I'm not going to provision them from the start like I would in a typical demo. So in this particular case, I've got a blob storage account. That particular blob storage account has got so we can see the account type is of blob storage. It's not generic storage account, but generic storage accounts version 2s are actually accepted in Event Grid. That particular storage account is got a blob container, which I've called test container, and that's got a number of different blobs in there. Now, I've already created a web app in my environment, and that web app is based on this source code available here. So you can actually, if you wanted to quickly start consuming events from Event Grid and you wanted to see what that looks like, it's very quick for you to adopt that. You literally just need to navigate to this website, scroll down to the bottom and press deploy to Azure. It's already got a template associated with it. It will issue you a brand new app service plan and a web app that can then consume events from Event Grid, and will create a particular endpoint that you can then call. And then once you've got the service that's going to be triggering the events, and you've got the service that's going to be consuming the events, it's quite easy for us to then create an event subscription. So all I need to do is type in Event Grid at the top. With that, 3 different services will come up, and we've got Event Grid subscriptions. So the Event Grid subscriptions, I can see that I've got already one subscription I've provisioned ahead of time, but we can create a brand new one very quickly through the portal or through Azure CLI. So I'm going to call this event ISV. I'm going to have this trigger from Event Grid schema, and I'm going to have this trigger from an Azure storage account. So I'll point this to the blob storage account that's in the same region, which is that blob storage account. And I'm going to say that what I want this to call out to is currently a webhook. So it'll be just an API service, a web app that's currently configured to accept these particular calls. So I've got the endpoint of the API app already, which is this particular endpoint. So if I copy that across, I'll paste that in there. Confirm my selection, and I can then choose to optionally use additional features. So if I wanted to configure that retry policy, if on failure I wanted this to keep on retrying, I can tell it to keep on retrying every up to 30 times and retry once every 2 hours. So I can configure that when I create my new event grid subscription. And all I need to do is press create. Actually, I'm not going to do that. I'm going to retry every minute because it's over 24 hours. Press create. And that, if my portal actually works, would create a new event grid. So what you end up having after a few seconds of creation is something like this. And I've got this particular endpoint that's going to be called every single time that account, that blob container has a new blob created in it. So you can, for blobs, have events trigger when a blob is created, and you can have events trigger when a blob is deleted. So I'll look at this particular app that's currently being called, and what that looks like is this. So I'll get the endpoint for that particular web app, which will load in here. And it's currently just a box standard web app for consuming event grid events. I will then introduce a new blob in that particular container. So we'll close this off. We'll go to the storage account, go to blob storage, and we'll upload a new blob into here, which is quite simple. We can use things like Storage Explorer if we wanted to, but I can do this directly from the interface. And what I'm going to do is I'm actually going to make sure that there's already a different file available for me to upload. So in my temp directory, I'll just copy this, paste that across. Let's try this again. Okay, this is taking a bit of time to load my container. There we go. I'll upload a new file. Select that from here. Test2, upload. And we'll see that as soon as that file is uploaded, an event is now triggered in our application. So it's as seamless as that. It's quite quick. It's all in a standardized format for those particular events, and those are all documented online. So I can see that through Event Grid, I was able to trigger an action based on a particular behavior in my environment. Again, keeping time in mind, just to make sure. Last but not least, we've got logic apps. Now, with logic apps, I've already talked about the benefits of serverless. There's no point reiterating the same point. And what I just want to reiterate is that logic apps allow us to seamlessly integrate with other services. So logic apps allow us to trigger things like, for example, on-premise BizTalk processes. They allow us to collaborate with other organizations through Azure B2B, and they have an intuitive interface. So they've got a very easy drag and drop interface where we can drag other actions, we can drag triggers in there, and we can also integrate with other services on the Azure platform. So cognitive services is a prime example. I've just had people wave at me to say that we're out of time. So unfortunately, I'm not going to be able to show you that. For those of you that are still triggering on the that are still staying on the platform track, however, and are not having to move into other theaters, I'll quickly do a demo of logic apps now. For those of you that do need to go on to other sessions, such as the business or the development sessions, then please do move on to the other sessions. Is everybody else staying here? No, that's absolutely fine. Well, we've got 10 minutes until the next one starts, right? Yeah. Cool. Yeah, absolutely. Okay, so very quickly what we'll do is we'll dive into that. And with the logic apps, for those of you that are staying here, it'll be nice and simple. I just want to show you exactly what it looks like, and we'll do that very quickly here. So I've got a new logic app I'm going to define. That will provision very quickly. But essentially, I'll define a new one just to show you how quickly it is to define, and I'll jump into one I've already created because it's going to be a lot easier for us to demonstrate what that looks like without going through the individual steps and looking to implement that separately. So I'm going to pick a name for this. I'll just call it Event ISV Demo again, keeping it simple. use an existing resource group because it's consistently easy to create new resources. And I'll create this in West Europe for consistency reasons. I can integrate with things like log analytics to extend my extensibility and things that I could do, but I'm not going to do that. I don't want logic apps to actually log to an OMS workspace or anything like that for me to report on at a later stage. And as soon as that's finished provisioning, what you can actually do is you can dive straight into that demo, and straight away, as soon as this loads, it will actually open up the designer view. So I can close the designer view, I can see some of the other settings in there. But the point there being is straight away, we've got different templates that we can start off with. So there is already tens of templates available for us for integrating with loads of different services. We can, if we wanted to, start with a blank template, blank logic app, and do our own thing. But what I've actually done is I've already created one for us to go through. So I've got this serverless logic example, and if I click on the logic app designer view, then you can see how easy it is for this to integrate with different services. So in here I've got a new trigger at the top. So my trigger is basically saying anytime a tweet is posted, that tweet contains the word ISV in it, I want this particular logic app to trigger. And I want this to check every 30 seconds to see whether that condition has been met. In there, I've got a different condition. Now, I'm also saying if the person that's posted this, if their name contains the name, well, my first name, with a weird spelling of Daniel, then it satisfies this condition. Now, shouldn't have done that. If that is then satisfied, what it will then go on to do, if I demonstrate quickly, is you'll go to use to detect sentiment. So this is done through cognitive services. I've defined cognitive services in my instance. I've pointed this to my particular cognitive services instance, and I've given it a key to use for that particular connection so that it can authenticate this particular sentiment analysis. And then what I'm basically saying is if it succeeds, so I can choose when this runs, and it's currently configured to run if the sentiment analysis is successful. What this is actually doing is then detecting what the sentiment analysis score is. If it's over 7, that generically means that the sentiment is positive. And in this particular case, if it's over 7, what this will end up doing is it will end up sending me an email. So what I'll quickly do is I'll actually run this. So I'm going to have this enabled, and I'm going to trigger it. And what you should see is a quick email, if I don't get kicked by my colleagues very quickly. So we'll enable, our service. We'll go on Twitter, and on Twitter we'll say, I am loving the ISV Partner Day so far, and I'll press tweet, and what that will essentially do is that will run in the background, I'll trigger, and if all things are successful and it likes my cognitive services key, which I'm pretty sure was unpopulated earlier, what you'll do is you'll send me a new email, although my connectivity is very, very dodgy through my hotspot, and you'll basically say a new tweet's been posted based on the defined layout. And if I run trigger now and hope that I don't have to wait the 30 seconds, something's just run, it's successful. And I've got this cognitive services. And basically what that's done in the background is it's gone, it's checked that I've incorporated the word ISV, it's checked that it's been sent by somebody called Dan. It's got my name, contains my forename in there. And what it's done is also it's analyzed that this has got a positive message and has actually sent me a positive email to say that that's been a positive message that's been published on that Twitter feed. So what this has done is it's incorporated numerous different technologies that are already defined on the Azure platform. I mean, it's really only taken me about 30 seconds to configure that workflow, which I did very quickly earlier this morning. And I hope you kind of found that useful in terms of serverless technologies. Brilliant.